Hey geometry. The learning target for today's notes is the same as our learning target from last time. We are still proving that two triangles are congruent using theorems and postulates. But what is different this time is that we are interpreting given information. So last time when we looked at trying to decide which congruence postulate or theorem proved our triangles congruent, we were given two triangles in a picture that had congruent sides and angles marked on them. This time we still get a diagram, but instead of having congruent angles and sides marked on it, we just have some information that we're given. So before we get into diagramming and interpreting that given information, we're going to do a quick review of some vocab words and things that we've used before that are going to start coming up a lot in these kinds of problems. So when you're given some information about triangles and you're trying to prove that they're congruent, you might get information that tells you that you have sides that are congruent. We saw this first one last time, the reflexive property. The reflexive property tells us that anything is congruent to itself. And in this case, it's that side AB is congruent to side AB. So that would be the statement that we write in a proof. And the reason that we write would be that it's because of the reflexive property. So we're not officially writing proofs today, that will be next time. But we are going to kind of get into the habit of thinking about what would our statements be and what would our reasons be that prove these triangles are congruent. So the next piece of given information we might get is that we have a midpoint. This time we know M is the midpoint of segment AB. So if M is the midpoint, that means my two sides are congruent. So in this case, because M is the midpoint, we know that AM is congruent to segment BM, and our reason would be because of the definition of midpoint. Another piece of information that might get us some congruent sides is knowing that a triangle is isosceles. So in this case, side AB would be congruent to side BC, because we know that an isosceles triangle has two congruent sides. So we could say that AB is congruent to BC because of the definition of isosceles. But there's actually some extra information we can get here. In an isosceles triangle, we also know that our base angles are congruent to each other. So the angles across from the congruent sides are also congruent. So I could also say that angle A is congruent to angle C, and our reasoning here would be the base angles theorem. You could also say because of the definition of congruent triangles, and that would be acceptable. The last piece of information that will get us some congruent sides is if we have a bisector. In this problem, we're told KM bisects JL. So what that means, bisecting means to cut into two equal pieces. So if KM is bisecting JL, then JL is being cut into two pieces. So we can say JM is congruent to LM because of the definition of bisect. Okay, so that's congruent sides. Places where we might find congruent angles. The first one we used last time. We can have vertical angles. So around point K here, we have a pair of angles that are congruent. Angle JKN is congruent to angle LKM because they are vertical. We can also have an angle bisector. So instead of bisecting a side, we're bisecting this angle. So when you're documenting that given information on your triangle, I would recommend you highlight the angle that's being bisected. If I'm cutting this yellow angle in half, angle ABC, I get two congruent angles here. angle ABD and angle CBD. And our reason would be definition of bisect. The next one includes a symbol that we may or may not remember from, I don't know, back in Unit 1 or Unit 2. This upside down T means perpendicular. And we know that perpendicular lines intersect and create 90-degree angles. So they are telling us, our given information says BD is perpendicular to AC. If those lines are perpendicular, it means that they meet and intersect to create right angles. If you are using this in a proof, there are a couple of steps that you would need to go through. So the first thing that we would say is that angle ADB and angle CDB are right angles because we had perpendicular lines. And then once we've said those are right angles, we can say that they are congruent to each other because all right angles are congruent. So this one requires 2 steps if you're writing it in a proof. Okay, third one. We saw an example that used this given information last time, but the notation might not be super familiar. These 2 lines like this mean parallel. They are telling us that line XY is parallel to line WZ. When we have parallel lines, we get tons of angle pairs that are congruent. So I'm going to start by highlighting and extending my parallel lines, and then by highlighting my transversal. In this example, they say that angle YXZ, this guy right here, is congruent to angle WZX, this guy down here, because they are alternate interior angles. So that is one pair, one special angle relationship that gives us congruent angles. Another angle relationship that you might end up using are alternate exterior angles. Those are also congruent. And when we have parallel lines in a transversal, you might get corresponding angles, which are also congruent. So in this case, the 2 angles that they're talking about are alternate interior angles. There's actually another pair of alternate interior angles here. We have this guy, angle WXZ. That would be congruent to this one, angle XZY. And those are also alternate interior angles. So we're going to try 2 problems together where we are given some information that we are going to interpret and document on our triangles and see if we can prove and determine which congruence postulate or theorem will prove those triangles are congruent. So our first given says triangle FHG is isosceles. That tells me I have a pair of congruent sides. So I'm going to keep track of what I'm drawing on my triangle and how I knew that information. So for this first one, we indicated that side FH is congruent to side HG, and we said that was true. We knew we could draw that because the triangle was isosceles. The other information that we're given is that HI bisects angle FGH. Oh, this is a typo. I forgot. We need angle FHG, sorry. HI bisects angle FHG, so that would be this guy up here. If that angle is being bisected, it's being cut into two equal pieces. So those two equal pieces are angle FHI, which would be congruent to angle GHI. And we knew that was true because we had a bisector. So we have one pair of congruent angles and one pair of congruent sides. If we think back to what our congruence postulates are, we need three pieces of information. Three sets of congruent things. Or if we have a right triangle, we can use hypotenuse like. We don't have a right triangle here, which means we need more information. So I used up all my givens. I diagrammed all of that stuff onto my triangles. Just from looking at the diagram, I can see that I have a reflexive side in the center. So the last thing that I can document here is that side HI is congruent to itself. And I can say anything is congruent to itself because of the reflexive property. So now that I have three pieces of information, I need to determine which congruence postulate this could be. So if I look at the information that I've got, I have a pair of congruent sides. I have a pair of congruent angles. I have another pair of congruent sides. So that points towards this is probably SAS. I need to make sure that angle is included. So if I look at my diagram, I want to make sure my angle is touching both of my marked congruent sides, and it is. So this one, those triangles are congruent by side, angle, side. Okay, we're going to do one more. Our given information this time. T is the midpoint of PR and of SQ. Oh, I'm going to back up for a second. Okay. When I'm looking at my given information, just from reading the information, I should know what I'm going to be drawing on my triangles. So if I have an isosceles triangle, I know that's going to get me two congruent sides. If I bisect an angle, that is going to give me two congruent angles. And those were the first things that we were able to document, a pair of sides and a pair of angles. Okay, so I'm going to go back over here. In this problem, I know T is the midpoint of PR. Well, if I have a midpoint of a segment, that's going to get me two congruent sides. And T is the midpoint of SQ. It's going to get me two more congruent sides. So here's T right in the center. If T is the midpoint of PR, that means PR is being cut in half. So I can say that PT is congruent to TR. And I am allowed to say that. I knew I could draw that on my diagram because of the definition of midpoint. Okay, I also know T is the midpoint of SQ. So SQ is being cut into two pieces. So I can say that ST is congruent to TQ. And that is also the definition of midpoint. So that was all of the information we were given. Looking at my diagram, I can tell that I have a pair of vertical angles here. So the last thing we're able to diagram is that angle STR is congruent to angle QTP because vertical angles are congruent. So I have three congruent statements. So now when I'm trying to prove that these triangles are congruent, Here are my options. Is it SSS, SAS, AAS, ASA, or is it maybe HL? If I look at my statements here, I have a pair of congruent sides, another pair of congruent sides, a pair of congruent angles. So 2 pairs of congruent sides and 1 pair of congruent angles suggests that this is probably side angle side. But I need to make sure that angle is included so that it's touching both pairs of congruent sides, and it totally is. This angle is made up of those 2 sides that we know are congruent to the 2 sides in our other triangle. So this one is also side angle side. There are 2 more problems on here for you to try. Try the bottom ones, diagram your given information, make your list, what were you able to draw on your picture, and then try your practice assignment.